Okay, in the topology, what is our topology? Topology is like router 1, router 3. When you perform the lab, as per the manual I provided, you can follow that guidance. But just for demonstration, we are showing a simple way. What we will do, we have two routers. Router 1, let's see router 1. So if we get brief, all are down. Why all are down? Okay, only one interface is up, that is 172.16.1.1. Okay. On other router, what is our IP addresses? Okay, we have three loopback and one interface. Okay. And we have configured a telnet on both ends, but we'll focus on what is our access control. In router 1, we will configure, let's delete all that. In router 1, we have to configure in this way, deny telnet from router 3, okay, from router 3. How we can deny? Say deny TCP network. And we have three networks like this, 10.10.10.0. Then we have 10.20.20.0. Then we have 10.30.30. If we summarize, we can say that it is /8 network. Okay. So subnet mask will be what is the subnet mask? Okay, like this, and the wildcard mask will be just the reverse. Okay. So from here we just deny for telnet. Telnet is port 23 and it is TCP, and we write this statement. So to any means from this network, any telnet will be disallowed in router 1. And we have also another network, that is a point-to-point network. We can also deny that network in router 1, and then we will implement line BTY 04, and in this BTY interface, we will just apply the ACL. Okay, then it will be blocked from router 3. That means what we are trying here is that we are blocking clients SSH or telnet in the ISP's network. Okay, this is our arrangement. So at first, let's try in the router 1. Let's see IP SSH. But already there is any. If I have already configured for testing IP access list, okay, no access list. So with this, let's try from router 3. So, telnet. 192.161.1. Okay. Okay. It is possible to telnet. Okay. Now we'll block all the networks from router 1. In router 1, go to connect. Anyone say anything? Any question? Okay. What will run this command? We'll just not true. We'll just write an SQL statement which is named SQL. What is named SQL? Look, if we write one by one again, with this statement, we are writing IP access is extended. This telnet inbound block. Okay, inbound policy. Okay, then we'll make the remark. Deny. What is our what will be the remark? Remark says.
17 network.
Yeah, we try to deny telnet from router 3. Somehow the copy is not working. A remark, okay. Remark in inverted comma, just write deny. Deny telnet from R3 client, okay. R3 client. So it is our ISP client. We want to block any access from them. Okay, then we have two other. So we'll just mention the routes or IP block. So we have 10 IP block that we assign to our clients. Then we will okay, right. And yeah, okay. Just we deny, then TCP, then the IP range with wildcard mask. Any means to anywhere. So we could specify the specific IP range, but we can also write here any for simplicity, and equal to means what is the protocol. Sometimes you can use unequal, not equal. That means you allow maybe 23, not 23, but all other. Okay, like this way. And we also denied point-to-point network. That is 172.16.1. Okay, then and we will apply this line. BTY04. Then we will apply IP access class. Okay, access class telnet in. Okay, telnet in. Sorry, telnet in which inbound. Okay, we just don't want to any traffic inbound to our router. Okay. Let's check from clients. Clients means router 3. Okay, let's try again. Okay, connection refused by remote force this time, because telnets are blocked in ISP router, that is R1 router. So in this way, you can block or you can block in your router from other routers or other IP address range that should not come to our network. Okay, it is security measure. It is one of the important security measure you must take in production network. Okay. Okay. Do you have any questions with regard to to access list? Today we have more.
So
Okay.
what if they have a loopback network? Like, can we go to the loopback interface for let's say .10 loopback
Okay.
10?
Good question. Actually, okay. One important thing I should mention, I realized last. Say I gave you some labs. You have to some modification in the labs. Then I am explaining about loopback. Okay. Look at this. These labs describes that we will use loopback to loopback instead of real subnet. Okay, let's look in this type of network. Say you will take a switch and then you will take the PC, for example. Okay, it is very important issue. I pointed out. Let's say we will connect and
Sorry, I joined late. Sorry for that.
sorry.
I joined late. I'm in the hospital. I'm not tonight.
Sorry, can you repeat?
It's okay, sir.
Sorry. Maybe network. Okay. What I am trying to describe that what is the use of loopback in the router. In some cases, we use loopback to test different commands or scenario. Instead of taking real subnet, say if we connect a switch with a say one sample PC with IP addresses, that means we have to assign gateway in the router's interface. That means that interface has a specific IP range. Okay. And with this type of IP range, we test different routing or different configuration. But for simplicity, without configuring PC or configuring IP interfaces of the router, we just create loopback address like this, okay, like this. But there is one limitation here. Limitation is that sometimes we ping, say you can ping a network. When you ping other network, then by default, connected interface IP address is the source in the ping. You know that ping, when we run ping, ping has two IP addresses. One is source address and other is destination address. Source address is by default your computer's address, and target or target address or destination address is the target we set. Okay, but we don't mention source as it is by default configured or by default taken. Okay, what if your computer have more than two IP addresses? In that case, you want to try with source IP address. Okay, so that is possible in real router, but in simulator I tried that it is not possible to ping with source in packet tracer. Or say when we, for example, when you ping, just ping without, then you have to mention protocol, and then target IP address. Okay. Then and press enter. Oh, okay. You have to mention IP address. Say target IP address is 172. 16.1.2, for example. Okay. Then repeat count. You can change the number. Then datagram size, you can also change datagram size. Then timeout. Okay, extended command and loop. There is no source source IP in the options. Okay, but in real router we can give the source. So if you have different interfaces, say loopback, then you can mention that ping with this source to the target. So this is limitation.
So sir, here can you go to the interface loopback, for example, here in RTL.
Interface loopback.
Yes, sir.
You
Let's
can
say loopback 10. Go to the
Okay.
interface loopback 10.
It is actually virtual interface.
Yes, sir. Can you go to that interface by writing, let's say configure terminal, then we should go to the
Okay. Connect
then interface.
interface loopback set 10. Okay. Then
Yes, sir. Then do. Yes, sir. Then telnet.
Oh, then telnet. Okay. Oh,
Yes,
from
sir.
here.
Yes, sir. Then telnet. Then
Okay. Telnet. Then IP address. Okay.
yes, sir. IP address of the destination 172.16.1.1.
Okay. Oh, it is also refused. Okay.
Okay. So because we block 172.16.2 network, no loopback can telnet the 16.1, right?
Yes. Good idea.
Okay. Yes.
Okay. Good idea. But okay, what I am trying to say is that when we try to ping, we are not getting here the source to mention here. Okay, so it is one of the limitations. But we can do. Okay, good idea. So this is one. But if you are unclear about loopback, then you can do the configuration like this without making any loopback. If you create or make the diagram in this way with a PC connected to interface, say you can also add a switch to make it more realistic. Okay, then it will be more understandable for some people. Okay, or if
Yes,
you are clear about loopback concept, then you can use loopback for simplicity, because your main focus is on your main topic, not the whole thing. But in reality, you have to do it with that everything. Last day we not last day, in last session or a few sessions ago, we tried some routing. We created a loopback address, say 8.8.8.8, just to indicate it is ISP's DNS, Google DNS. Okay. But in reality, it is a loopback address, and we also configured a network static dynamic, default route to this IP address, right? So
Yes.
that is if that is clear to you concept, then it's no problem with loopback address. But we have also real functionality with loopback addresses in production network. That is for management. That is for OSPF routings, router ID, for example, and for other testing purposes also. We use loopback address, but in this lab environment, we use loopback address for simulation or imaginary entity, imaginary network. Okay.
Yes. So it is
Okay.
always a good idea to block the whole network if you are blocking the telnet rather than a specific host, right?
Yeah. Okay. Okay. Let's proceed with today's topics. Today we'll cover two things. One is network address translation. That is very important for your real life activities. And also we will discuss some WAN technologies. That means wide area network connectivity technologies that we use in our production network. Okay. At first, we will go through some network address translation concept. You know that IP version 4 is 32-bit long. So maximum IP address is to the 32th power, right? IP addresses. But there are also other divisions. So IP address will not that much in reality, because we can use A, B, and C classes, and D, E classes are used for special purposes. For example, D is for multicasting, and E for some research purposes or reserve. Okay, so it is not used. So we have class A, B, and C. So experts anticipated that those IP addresses will be exhausted at some point. Okay, so they thought that they will have to more larger IP address space. Okay, 32-bit is not enough. So there are different researches. You have you may go through those historical background, but I will not. Finally, the first IP version 6. But there was a fear that IP address will be exhausted. Okay, there will be no IP address for use, because 32-bit address is not enough for to cover all the devices people have across the world. Okay, but one technique was developed, that is network address translation, and private IP address is key. So we have 3 blocks of private IP address blocks that you can use in your internal network without considering other organizations. But one limitation is that if you want to go to the internet, you will not be able to go with those private IP addresses. You have to convert it to or translate it to public IP addresses. So that is called network address translation. So when network translation was widely adopted then IP version 4 exhaustion on did not happen till today. So IP version 6 utilization and became quite slower, but people are adopting nowadays. But what I am trying to say is that network address translation and is important for every organization. In your internal network, you of course use private IP addresses. Okay, that you don't need to purchase from any authority. But when you go to the internet, you must purchase public IP address from your internet registry, or ISP can also provide you IP address block. Okay, so you have to pay for those IP addresses. So IP address is costly. So people use organizations use very few IP addresses, public IP addresses, and they have huge private IP address that they can use on their own. Okay. So how we can translate private IP addresses to public IP addresses? So there are two approaches. One is static mapping. Static mapping means you have a private IP address, then you will just map to a public IP address one-to-one, just one-to-one. So one-to-one mapping has advantage and disadvantage. Advantage is that you can specify a specific address translation. That means you are sure it is what is the host. Say if it is a server, when we sign public IP address to a server, we don't need translation. But when we use private IP address to the servers, then we have to address mapping, one-to-one address mapping in the router. Okay, in the router or in firewall, we can configure net. Okay. So one-to-one map means you will need many IP address, public IP addresses. So that is the limitation. But in case of server, you cannot do other type of netting. You must do it one-to-one, because your server is fixed. Say you have a website, web server, okay, and it has public IP, private IP address for some reason, but you have to map with specific public IP address that will be in the DNS entry. So people will hit with this IP somehow. Okay, they will hit with the name, and DNS will convert it to public IP address. Public IP will then hit your router or firewall, and router or firewall will translate it to your private IP address. Then the server will reach. So static net is used here. Okay, in this type of server. In case of server, you do a static net. Okay, there are another way of netting, that is dynamic net. Okay.
So, sir,
Okay.
you have to buy a public IP address for each of your server.
Yes, for each of the server, you have to assign public IP address, separate public IP.
Okay.
Otherwise, you will not be able to identify which server it is. Okay. But there are other port address translation is one approach that is not actually effective. But what we do, we just assign separate IP addresses for each server. That means public facing server. If the server is for internal use, then you don't need to configure any public IP address. Okay.
Yes.
There are some command syntaxes. Okay, let's explain static net path. Static net, what we do, look at the figure. Let's see in the figure. We have a server, say, for example, just call it server 10.1.1.2. Okay. And we have a router disconnected. Okay, maybe there are switches in between. Okay, just it is ignored here, just for simplicity. Then we have another interface that is connected to internet. Okay. In this scenario, imagine 192.168.1.1 is imagine a public IP address, for example. Okay, it is not public, it is private IP address, just to understand. So this server, so people try to reach internet, or you can say, if you think it is just computer or it is server, it want to receive, reach internet. So what it will do? It will send a packet to router with the source IP address of the computer or server, which is a say private IP. So router will translate it. So remember one thing, I am talking about private IP to public IP address translation, but it is possible that you can translate private IP to private IP, or public IP to public IP translation is also possible. Okay, that is not easy. But in practice, we use network translation in most cases. I would say almost always, with some exception, we use network address translation only when we use private IP to public IP conversion or mapping. Okay. So in router, the source IP will be changed as other IP, which you configure. Okay. And destination IP will not be changed. Okay, it is just source IP address will be changed. Imagine. So how we configure in the router? Router has two interfaces. One is towards the computer or server. It is inside. Okay. In that case, the command is IP net inside, and where it will be translated to, that is your IP net outside. Okay, and finally the net you will define. The command syntax is IP net inside source static, as it is a static netting. Okay, then you will mention on which IP will be which IP will translate to which IP. Okay, in this scenario, we are going to translate 10.1.1.1.2 IP to 192.168.1.2. Okay, we just want to translate it. Okay, then how we can verify this command is working or configured properly? Show IP net translation. Okay, you will see. Then IP inside global, and inside local to inside global. Okay, this is just static one-to-one map. Okay. So the number of public IP address record is the number of is equal to the number of hosts you will use, host or server. Okay. Then we have, okay. You have any question regarding static net? Okay, maybe. But we have dynamic net address translation. Okay. Dynamic net is bit different, where we have a pool. Say you have 500 employees in your organization. Okay. So you will not purchase 500 IP address for 500 computers. What you will do, you will purchase say 10 IP address from your ISP or from your ISP. Okay. Because you know that although you have 500 employees, not every employee will connect to internet at a time. Okay. They will connect with some people will connect at a time and another group of people also another time. So we don't need many IP addresses, or say 10 IP addresses is enough, for example, or 20 IP addresses, for example. You will participate. Then you will define a pool. You know about pool. Pool means shared resource. Okay. You have a group of resources for a group of users. Okay, that is pool. So you define pool and you define net that when any host want to go to the network, they will take IP address from the pool, which one is available. Okay. So how we define? At first, we will define the net pool, and give a net pool name, whatever your choice, and then you will define the range. Say 171.69.23.2092 to 222. That means how many IP addresses here? Say here around 11, 13. Okay, 13 IP addresses are there, and net mask we will mention subnet mask of this IP range. Okay, it is your pool. So when anyone goes to the network, internet, they will use IP address whichever one is available, and then it's IP net inside source list pool net one. This is the syntax. Okay, IP net inside is the previous command for a static. We mentioned a static, but it is not a static, so we will not mention a static. Source list one. List one means we will define the access control list. ACL has many uses. In network address translation, we also use ACL. So please try to be clear and practice with ACL.
So, sir, here, is it optional to apply ACL?
Yes, no, in a sense optional. You can use a specific range, or if it is simpler, but in practice you need to configure ACL, because you have to deal with so many IP blocks inside the network, and for different reasons you have to change them, and you have to add some policy. For example, if you want to block some services, say we don't allow HTTP, In that case, you change this access control list statements. Okay, so you can apply policy with ACL and add, remove IP addresses without changing the original net statement. Okay, you just define access control list in the net statement, and you will not touch it frequently. You will just change this ACL. Whatever you define in ACL, that will be effective in network translation and command. Okay. So here the command. Okay. Here net inside and outside command is same. The inside interface is IP net inside, and outside under outside or internet bound interface, you define IP net outside. It's just pretty straightforward. Okay, and then you define the access control list one permit. Say there is IP address block and then wildcard mask. So if want to specify the specific IP address and deny, you can also mention here also. Okay, if you want to deny specific IP or network, then you can also define in ACL. It is so two things. There is a definition of pool. Definition of pool is pretty straightforward. Just define the IP range with subnet mask and give a name to the pool and apply to it net transfer. It is dynamic. Okay. When your users or computers increases, then you may need to increase the number of IP addresses in the pool. Okay. I'm just talking about production network. Okay, this is dynamic address translation. Then we have, okay, there is some troubleshooting. Okay, you can go through yourself just for your understanding. But what is most important in production network is port address translation. Okay, PAT port address translation is mostly used in production network for internet users. Okay, even in our home network, we are using actually port address translation. Okay, we don't have a IP pool in our home router or in production network. We also have a pool that is smaller numbers. We have around 10 to 20 IP address at best. But 10 to 20 IP address is not enough for 1,000 users, for example, or more. So what we do is we use port address translation. How it is done? You can use with one IP address. You can have around 65,000. Around 65. Let me write down here the number 6535, maybe this figure. Okay. The number of connections is possible with PAT with one IP address, one public IP address at your router. So how it is done? So for with all session, say you have one IP address and then assign a port. Okay, that you can call it socket. Okay, so for one session, you can assign IP plus port. So in this way, we can connect as more than 65,000 connection. It is also called net overload. So how it is done? Okay, let's look at this figure. Say we have one IP 10.10.10.10. Okay, so this computer wants to reach an internet server somewhere. It is IP would be 20.30.40.50. Okay, it is public IP address. But with the private IP 10 series is private IP address. Private IP with private IP address, it is not possible to reach that server. So there is a firewall or router in our edge border perimeter of our network. So what our router or firewall do, they will just intercept the request, okay, or just receive the request from the computer. So from computer, it will have two things. It has a source port and a source IP address, okay, and it has a destination IP and destination port. So it went to a web server which is 443. Okay. So in router, it will change the source IP address of 10 series. Then it will assign another IP address 100.99.80.77, for example. One public IP address is assigned, and now the the new packet is source IP address is with this translated IP, and it has got a port also. And the destination port and destination IP and destination port is unchanged. Okay, it cannot be changed. So we have got it. So when the router or firewall receives another request from another host or computer, then it will send the same packet. It will change or assign same source IP address, but with different port. So with port, it is changed. So in the lower part of the table, look at this. So say we have 4 sessions. Okay, from computer 1, IP address is 10.5 to 10.10 in router 10.21. Another is 10.21. That is from same computer, we can have several sessions. Okay. Okay. Any question? Okay. Then look at source IP address, source port. Every session or request has a source port of source port and destination port. Okay. And look what is done. Destination socket is same, IP address and the target service port is same. Say if HTTP, it is 80. If HTTPS, it is 443. So IP address is translated. Public IP address is same for all the sessions, for all computers. Okay, but port, source global port is different for different computers, and this is why port address translation. That is why it is called port address translation, because it depends on ports. Okay, it depends on ports because source is source IP after translation is same for all sessions. So router or firewall keeps a address translation on table, and with this, when return traffic comes to the router, it will again translate and send it to the requester. Okay. So it will look up in this table that which one requested for this. Okay, we have got request, because server will not know which inside host sent requested. It server, internet server or remote server will see only the public IP address and port and nothing else. Okay. So it is used widely, and for a small organization, they may have got one IP address. Say in our home router, for example, we have got one IP address, and we have several users or several devices in our home. Okay. So sessions from all those devices are using only one IP address. How router differentiate with assigning different IP different ports, and they are assigned dynamically. Okay. It is widely used. However, for large organization, they don't use one IP address, they use a pool like dynamic IP address. Okay. They have a pool with port address translation, that is, they can serve huge number of users. Okay. Port address translation, same. Okay. Once command, let's talk about command. Inside net and outside net command is same here also. But we can also use SCL for permitting or denying IP addresses like dynamic. But there are slight differences. So IPNet inside source list one. Okay, list means SCL list. And then we can also use interface 01 overload. Okay, interface 01 in default routing, we talk that we can specify IP address or interface. Okay, for routing. Okay. Here we just create an interface gigabit 01. That means all the requests will be translated to interface 01. That means internet, say S1 is internet router in the left diagram, and G01 gigabit 01 has IP address 158.4.12.1. Okay, this is public IP address. So translate with this. Port address translation will be performed with this IP address of the interface. Okay, and overload keyword is used to indicate that it is port address translation. And net overload. So some people call it net overload for this reason. Okay, and show IP net translation is the same for all. Okay, so we have some net related net labs that you can use. So let me show one. Then you can complete all. Okay.
Yes, sir.
Okay. Static net is important say we have also another two concepts you may encounter, that is source net and destination net. Source net is used when we use internet connectivity. Okay, say you are using a computer for internet connectivity or internet use. So it is source net actually. Okay, your IP address will go to the router, and router will translate it to a public IP address. And there is destination net. Destination net is when we talk about servers. For servers, people want to reach a specific IP address. Okay, so that IP specific IP address go to the router where server is connected. Okay, and router will translate to the private IP address of the server. Okay, so it is destination net. So we have a scenario like this. Okay, in this, although this lab is a bit complex, as it added switches management IP address for network address translation. Okay, it could be simpler. However, we will follow this. And there is also a serial interface. Okay, DC and DT. But when you practice, you can just connect to router with simple Ethernet connectivity. Because nowadays we don't need to work with serial interface. In fact, I never used it. I never faced this type of connectivity. But actually, in old days, there was some of this type of connectivity. And nowadays, all are Ethernet fiber-based connectivity. Okay. We'll take a topology, and then we'll okay. In this lab, you have also a configuration for switch management. Okay, for some reason we want to use that switch management IP with say telnet, for example, and it will have a private. Generally, we have private IP addresses for switch management. But what if we want to manage it from a remote site over internet? In that case, you have to translate that IP address with another IP address. But in the lab scenario, we don't assign the public IP address. We also use private. That is private to private translation, just for lab purposes. So you can follow with the switches management configuration. That will be also good for you. But let's try with simpler, to make everybody understand it. Okay. Okay, we can also use this scenario. How can we do that? Okay, say it is ISP. Let's ISP router. Okay, it is our users router. Okay. So as we can use, what are the IP addresses here? So interface brief. So IP interface brief. Okay, we have. So let's configure the IP address for the computer. So, config the interface gigabit. So we setting IP address by IP address. For 3.1. Oh, sorry. 0. Okay. Okay. What will be the IP address of PC? Let's take IP address of 10 or 3. Dot 2. Oh, sorry, 140. What? Okay. Let's check whether gateway is reachable. What? 1. Okay. 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 Gateway is reachable here, but we have what about routing? So I see route. Okay, we have static route, no problem. And here we should have a dynamic route. Sorry, static route. So run. What about our? Okay, we can add another route. Okay, just to make it reachable. Okay. Okay, IP route. We will add one route, IP route. What is the target IP address? IP network 10.40.40.0 subnet mask dot 0 and through which interface the 0/0. Let's see. Show IP route. Okay, let's see. Okay, we are getting our route from ISP. Okay, from ISP it is reachable. So here it's loopback address. Connect IP loopback. Sorry, IP not interface. Interface loopback. So 1, 2, 3 loopback. IP. start. If I want to try this IP, it is pingable from ISP. Okay. What if we want to try here? Oh, we are making one mistake. Okay, let's try. So, okay. We will not give routing. Okay. For this network, there is okay. Yes. Okay. Look, as we are making network translation, and look, so okay. Look, we have already configured static route, but we will not do this. We will actually give route to other IP block that will be translated. Okay. Okay. Let's remove all four routing. Okay, we will remove them. Okay, just try. What we will do, we will give a network static route towards this, which will be our net. Okay, say we want to net different IP block. So what is our point-to-point IP? 172.16.1.0. Okay, that's static. Not static. Static. Okay, what will say 172. 172. 16. Say whatever. 50 slash say 27. With 27, what will be the subnet mask?
255.255. 255.254.
254, right?
No, not 254.
224.
224, yeah.
Okay, 224. Great. So our one connected route is point to point. Okay, be clear here. One thing. For other purposes, we already configured IP route. We will delete them. Okay. Our net, for example, you imagine it is a public IP address. Imagine just this 27, for example. Okay. So we will define IP route for the with this. Okay. We are working in ISP router right now. Okay. In ISP router, we will not give route to private IP address. Okay. Let's go to ISP and just remove. Okay, just remove. Let's see. show run. Okay, there is no routing towards our client IP address. Okay. Now what we'll do, we will just give a route to an IP block that will be used for net. Okay. 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 So IP route. Okay, look. In this routing table, we have got 172.16.5.0/27 network is there. Okay. And we have point-to-point connectivity. So what we will do? We will assign some IP address for net. Say from this network, what can be IP address? Here IP address can be say 5.1. Okay. 5.1 for example. Okay. Let's assign this IP to our PC IP. Okay. PC has IP of 10 series. Okay. So in this, we will define a static route. So IP. Okay, let's look. So one IP is connected, 0, 0 is connected to ISP, and 0, 1 is connected to our computer. Okay. So we have to define inside net and outside net. Okay. What is inside net? Interface 0. Here we will define IP net outside. Okay, IP net outside. That means it will translate it to the IP towards the outside. Okay. Okay, done. And now we will define inside where the device is connected, whose IP you want to translate. Okay. Where is it connected? It is connected with this interface. With this interface, but it should not.
Preferences.
Yeah.
Need to enable it.
Yeah. What is happening? We want to enable gigabit 01 as net inside, because our host or computer is connected to this interface to switch. Okay. So on router, what we'll do? Okay, gigabit Ethernet 01. Okay, what is the IP net inside? So it is the source. Now we'll define static net. What will be the static net? Our command is let's say close. Okay, here, what is our command syntax? Can anyone say? IP net,
Not
Then?
static,
then
static, I think.
a static IP net source. There is source.
Yes.
Static. Then a source IP address, which is our 10 dot our computer address. Okay. We want to make our computer can reach internet. Okay. Look. It is IP2. Okay. Static, and then what will be our translated IP? We want to translate it. Okay. To it. Okay. Is it correct? Whether our command syntax IP net? Oh, sorry. Inside source. I also made a mistake. Inside source. Okay. IP net inside source. Okay. Look, before executing command, let's check if we can reach from this. Okay. What we are trying to reach? No. Okay. Can we reach 172.16.1.1? No. Although there is default route, will not be able to do it. Even there is default route, but you have to allow from upstream. In the okay. Now run the command. Okay. Let's say this is our command. IP net inside source. It is a static one-to-one routing in our internal computers. IP address 10.40.40.2, and it should be translated 172.16.5.1, which is which has the static route in the ISP. Okay. Let's say now try from here. Okay. Now working. At first it takes some time. Okay. Okay, now you can reach ISP. Is for a okay. You can also reach 8.8, which is a loopback on ISP router. Okay, you can reach internet. You can say. Okay, is it clear to you how we what we do in our own router? We just configure default route. Okay, and then we configure net. From upstream point of view, say you are thinking about thinking from ISP's router. You can reach upstream or internet only when ISP router has static route to your network. Okay, if your IP blocks are allowed in the upstream, you can go upwards. Otherwise, you will be confined to your network. Okay. So here the IP blocks to which you will translate your internal IP addresses are allowed through default route in upstream router. That is why your net is working. Okay, your net will work only if there is upstream route to your network. Okay.
So imagine we have many hosts on our network. Does this affect our network performance?
If you have many hosts, you have to assign one IP for each, one different IP address for different host. That means one IP address for one. So there is no performance issue with static net because one IP address is dedicated for one host only. So it is the best for performance issue. Okay.
Yes.
Performance issue will occur when you are using dynamic route. Maybe you have many users. They are trying to reach internet concurrently. In that case, some people may not get chance. Okay, that means some computers will not get connection and whenever they try. That is performance issue will arise. Okay, in that case, you have to raise the number of IP addresses in the pool. Okay, or you can use PET. With PET, you can also face performance issue if you have huge users while you have one or two IP addresses. So to get optimum performance, you make ensure that you have enough IP. Enough means you have sufficient number of IP addresses, and you also check the sessions. Okay, if any sessions are dropped, okay, you can monitor from your router. In that case, you will purchase more IP addresses, then it will be resolved. Okay. In this lab manual, which I am going to provide you, here is the same thing is they are configuring, but one difference is that instead of using a PC, here a switch is used with a management IP. You know, switching has nothing to do with IP address. Okay, but switch can have management IP with which you can connect the switch remotely for management or monitoring it. For example, network operations center has different monitoring, performance monitoring and availability monitoring tools, and those tools connect with the routers and switch using their management IP. Okay. Also, some syslog servers which will collect logs from different devices using these management IP addresses. So it is important to configure management IP. So here, as a bonus, you will configure management IP, which I already discussed in previous labs. And with that IP, say that IP is private IP, for some reason we will to translate it to other IP address. That is done with this lab. Okay, and it is also static. Of course, for management, in case of management IP, you need to do it static address, because one-to-one and translation is required, because if you use it with dynamics and from outside, it is not possible to locate it. Say we have internet connected computer, but they are not reachable from internet. Okay, because their specific IP is not available in the internet. Okay, from internet only public IP is available to outsiders. Okay, that is why our computers are not reachable. To reach our computer from internet, we have to install another mechanism that is different. Okay. Okay, let's move on to the dynamic. Okay, we have also dynamic lab. You can do that also yourself. Here, difference is that we use a pool loop. Here we use ACL access control list. We discussed that ACL can be standard and extended, and also it can be numbered and named. We can identify them with a number, or we can assign a name, whatever we want. Like here we use a standard extended ACL, net ACL, then we add a remark. Okay, then we assign a permit command. Okay, permit. Okay, in net pool and net command, what is the difference? Net just we made IP net, then pool dynamic. The pool is defined earlier. Okay, pool is defined. Okay, you will define a pool. You will define a pool with some IP address. Oh no, here we define pool. IP net pool dynamic net, then IP range, then prefix length or net mask. Okay, which one can be executed? Okay, then net. What is net? We just use the names or access list and pool defined just before. IP net inside source, then list. List means access control list, which allowed or disallowed, and then we will mention the pool that we define dynamic net, and then it will work. Okay. Let's another example. Okay, lab pet. Okay, pool base. Okay, there are two other labs that you will also perform yourself. One is pool pet pool base and pet port base. Okay. What is the difference between them? Port base means, say you have a connection with your ISP is router. So your router has an connectivity or port towards ISP, which has a point-to-point IP. Okay. So you can get that point-to-point IP, which is public IP, of course. Okay, and that public IP can be used for port address translation. That means all the internal connections session request will establish session with that only one IP address. Okay, and that ports only one IP address with different ports. That is why it is port based. And pool based means for your large organization, it will not be sufficient to use only one IP address. Okay, it will not work there. It will performance will be very poor there, or some people may not be able to even establish that. Okay, so in that case, you have to assign a pool instead of a specific port or interface IP. Okay, in that case, you pool based, you you will use a pool here. Okay, just I am showing one simple port address translation with this lab. Okay, it's very simple network. So what we'll do is it with interface? Yes, it is interface, using interface. So we can do it with this setting. Okay. So we'll remove our static net command here. So we have nothing to do with IST. Okay. We have to do here. So here okay, we will just remove our one-to-one net command. So let's check from our computer if we can reach internet. We should not reach internet because we have no network translation towards office space. Okay, lost, 100% lost. So we are going to run the command, which is the command. Everything is same here, but we will change two commands. We will create a CL, whether it is standard or extended. Let's copy here, then we'll edit, then we'll just at first we define access control list. What is our IP address? Okay, same. It will work. Okay. This what is our okay? We can no, not do that. It will work somehow, but we should not do that. Okay. Our access list is permit just here, and what we will do, our inside and outside definition is also same, but what we will do, our exit interface is gigabit 00. So IP net inside source least one, that means IP address least one ACL, and then we want to use IP address of gigabit Ethernet 00, which has an IP address, point-to-point IP address, and then overload. For PAT, we will use this. Okay. So now let's run these two commands in the router. Okay. So with this, we allowed our IP block, which can use this network address translation IP. Okay. Now go to again router. Okay. So IP net translation. Okay, let's run traffic. Okay, now you can again okay, now you can see translation. Once your traffic is gone through. Okay. Now, if we use another computer, what will happen? Okay, let's connect another computer. Computer, this PC, and we connect this port 2, even IP address here. What it will say 10.14.254, for example. Okay. Okay, from terminal, sorry, what I'm doing from command prompt, say ping. Okay, we can ping. Now let's see what is the translation. Okay, okay. We can see and from 1.2 IP. From 1.2 IP, we have a request to ICMP, that is to 8. That's what 8 actually. And inside global, it requested a packet with 26, 27, 20, 29 port. Okay. And no, sorry. It requested from the computer is 10.40.40.2 with 26, 27, 28, 29 ports. Okay. And it was translated to one IP address, 1.2. And with that, it reads to destination IP, 8.8.8. So again, we sent another traffic from another PC, that is that's IP is 10.40.40.254, and it used 4 ports, 1 to 4 for 4 packets. Okay, and the ports also translated, and it reads. Okay, and this is called port address translation. Okay. So what will be differences in in case of using your pool? Okay, so here we used only one IP address. Okay. That is interface IP address. Okay, in the routing command, you see that 1.172.16.1 just interface command, interface IP. Okay. Do you have any question regarding net? Then we will go through some concepts and then we'll finish. Here is Abdullah yes, today. He has no response today, and others also not talking.
Yes, sir.
Present, sir. Present.
Yeah, Abdullah, do you have any problem with this net concept or anything for configuration?
No, sir. No, sir.
Okay, great. Make sure you all practice with all the labs, and you will be well versed or very clear about everything. Okay. So I will share all the labs now, and we'll go through some concepts of okay, now it's sharing. Chat. Okay, in chat everything. Okay. Let's share. Fine. Okay, one is okay. Okay. Okay, maybe I should close it. Close it. Back. Okay, can you see all the labs delivered to you? Okay, I have sent how many labs there? Oh, 5. Okay. Then I will discuss some one wide area network technologies that you need in real life. But what is one? One means when you need to connect networks in a wide geographical area, say it may be countrywide or even across different countries, for example. If you have different offices at different locations. So why we need wide area network connection? Because we have one main office, headquarters at some place. Okay, then we have different remote office or regional office. Okay, we have to connect them with private network or organization network. That is why one concept is required. So there are different technologies such as frame relay, ATM, SDLC, which are actually quite old legacy technology. We don't normally use them nowadays. We just use other technologies that I mainly focus today. Look, there are some connections like CSU, DSU, or some serial connections. Actually, these are rarely used nowadays. we use what we use. Also, what I am nowadays, what we use Metro Ethernet. Okay, Metro Ethernet. What is Metro Ethernet? Metro Ethernet is provided by service provider, and the clients can connect to the Metro Ethernet, and whole Metro Ethernet can be regarded as a switch. For example, say you have a headquarters in the capital city Dhaka, for example. And you have another branch office in say, Gazipur. So how can we connect the branch office with our headquarters? There are several ways. Some are very costly and difficult to implement. For example, we can establish dedicated fiber cable between two, but you cannot do that for two reasons. One is cost prohibitive. Okay, it is so costly that there will be no business case. And another reason is regulatory. So government will not allow you to cut the roads and lay cable. So government will only allow some specific operators which are licensed. Okay. So you have to purchase or lease fiber cable that can be used to connect to offices, but that is also costly. So there are some multi-tenant solutions like Metro Ethernet. So some network is already exists. They are constructed by some service providers. Okay, like ISP or telco. They use their network for connectivity. So they have some point of presence, which we call POP. So you just connect your network router or switch to nearest POP via service provider router or switch is connected, and they will route this traffic to another POP. Say in our case, say in our office in Gazipur, where branch office is located. So in branch office router and switch will be connected to the POP nearest POP of the service provider. So between the POP of the service provider, our service provider is responsible for internal connectivity, or they have a network that can provide you layer 2 connectivity. So you don't need to share routing information. So you will see that your headquarters router and branch router can establish peering. Okay, no other devices in between. So this type of service is possible with Metro Ethernet, which is provided by Metro Ethernet service provider like ISPs. Okay, so the network diagram would be like this. So in the cloud-like figure, can you? Is it shared? Okay, can you see the slide? I'm a bit confused.
Yes, sir. That's it.
Yeah, great. So we have a user router, then we have different routers, and these routers are connected to a POP point of presence router or switch actually of service provider. So they provide connectivity between these locations. Okay, you will just pay their charge. So as the network can be used by multiple tenants or clients, they are a bit cheaper than laying dedicated cable or leasing dedicated fiber connection. Okay. So in many countries, Metro Ethernet is available. Metro Ethernet can be point to point. Say you have only one office in Gajipur, branch office, and you have headquarters in Dhaka. So you are connecting them on a point-to-point basis, which is called E-line. And what if you have one head office, headquarters office, and then you have several offices across the country, say in Bangladesh. So how will you connect them? You can connect them using two different approaches like full mesh. Any office can connect to any office. It will be a mesh-like connection. That means any point, any office can connect to any office. And another approach will be hub and spoke. That means all branch officers can connect to head office. If they want to reach another branch, to go through headquarters. Okay. So point-to-point connectivity is like that. There is two routers, two sites, and in between you have metric cloud. And you have full mesh. You can connect from anywhere, and you can. And hub approach is like this. Okay. And which approach is mostly used in our country is MPLS actually. Okay. Multi-protocol level switching. It is from connection point of view, it is similar to Metro Ethernet, but it can use different technology. So, large internet service provider which operate nationwide. Okay, they have MPLS network. For telecommunication network, for telecommunication operators, say in our country, Bangladesh, we have several network mobile phone operators. They have established large IP network, which is actually MPLS. Okay. So they can carry IP traffic from different clients. Okay. But this MPLS connectivity has advantage and disadvantage. Advantage is highly reliable. Okay, they can, and they have service level agreement with you that will guarantee that your service will not suffer any performance issue, or they will not be down. That is that it is highly reliable, but the charge heavily. It's costly. But large organizations use MPLS connectivity. And what is this connectivity like? It's like it's similar to Metro Ethernet. There is MPLS cloud. Your office router or perimeter router will be connected to the router of the service provider's POP or site where you just connect. Okay. And your branch service will also connect to the nearest provider as router. Okay. So in between, the connectivity will be ensured by service provider. You are responsible only for your router. Okay. And you pay charge for connectivity bandwidth you purchase. So but here another issue is that you have to establish local link. Okay, there are several ways you can establish your connection to the point of presence of the MPLS operator. Say your router is 2 kilometer or more, say 10 kilometer away from the router of the service provider. So how can you establish this connection? So there are different techniques that you can use. You can use radio link, okay, point-to-point radio link. You just install a radio at your roof of the office or building, and another radio at the site of the service provider. So there will be a link. So in this figure, it is not shown. Okay, it's shown 4G, 5G technology. 4G with 4G and 5G card in the router, you can also establish link. Okay, using again using mobile phone network for point-to-point connection. Or another option can be Metro Ethernet connectivity between your router and the service provider router. And another option is cable TV connection. In some countries, although it is not popular in our country, people had cable TV connection. It's coaxial cable. With this cable, they use a modem for internet connectivity. So they can also provide connectivity using cable TV operators network. Okay. So in this way, you can establish connection between your site and service provider site. So MPLS is used in the core of the service provider network. It is label based. A label is assigned to IP packet. Okay, using that IP packet label, packets are transferred instead of IP address. Okay, IP address are encapsulated in labels. Okay, that is not MPLS network. Details is not in CCNA course. Then CCNP level or and your own interest, you can study further because it is very interesting area and it is used by a large telecommunication operator and ISP, which operate nationwide. Okay. And another option for a wide area network. So I told that a Metro Ethernet can be used as interconnection, MPLS network can be used, but these are a bit costly. So you have a cheap solution if your organization is not so big or has no huge financial strength. In that case, they can go for cheap solution. So what they can do, they can use internet connectivity in the local. Say, your branch office is local, Gazipur, you will just connect to local ISP. Your headquarters is in Dhaka, you connect to internet, and in between, you will establish VPN, which can be Gre tunnel or IPsec tunnel or both in combination. So IPsec is used for confidentiality or for encrypted traffic. Okay, so no one can see what is going through from you between your officers. Okay, if you use Gre tunnel only, then it will be open for all. Anyone can see what is what in your traffic. Okay, so we can use Gre if it is inside network or something. So what is Gre tunnel or IPsec tunnel? It will use establish a tunnel between two network over internet, okay, over public internet. So what is the advantage and disadvantage? Advantage is that it is cheap without investing huge money or significant amount of money. You can establish internet VPN. But one downside is that performance is not guaranteed. Your bandwidth may fluctuate. Sometimes you get enough bandwidth, sometimes you will get poor bandwidth, sometimes connectivity may be loose, it may get down. So that's not the problem with regard to internet VPN, but they're cheap. So these are the ways that you can use to ensure wide area network connection. There are modern concepts of Cisco SD-WAN, software defined wide area network that is used for used with multiple connectivity to your office, whether it is branch office or its headquarters. Okay, you have different connectivity, wide area network, software defined wide area network has some intelligence. It is also called intelligent one. It can monitor your connection status based on its performance. It can dynamically switch between connectivity and the distribute network. So it's also advanced technique that we may further discuss in software defined networking session. You can study it because nowadays SD-WAN are being adopted by many organizations. Okay, do you have any questions to discuss further? Then we can close today's session. Tomorrow we will also conduct part from 9:30 to 11:30. Okay. Okay. Do you have any questions or anything to discuss, or you can add anything? What about others? Today, MDICO was discussing about things. What about Abdullah?
Nothing, sir.
Okay. Do you have anything or anyone else has anything? Then we can discuss or we can finish today's session. Okay. Tomorrow we'll start 9:30 so that we can finish earlier. Okay. Thank you all.
9:30 a.m. or p.m. sir?
Sorry.
9:30 a.m. or p.m. sir?
9:30 to 11:30. Yes.
A.m.
AM. Yes. Yes.
But
Yes.
we have lab tomorrow at that time.
Yeah. Because we want to finish within this month, as you are requesting.
We have lab tomorrow.
Yeah.
At that time.
Some of us, we have another lab, not this lab.
You will log in 9:30.
Yes,
No,
sir,
sir.
but we have another lab, not networking lab.
Sorry. Network lab.
I mean,
We
tomorrow we have another lab, not this lab. At that time.
We have final lab presentation for another course.
Okay. Oh, this. Okay. Oh, I missed this. Sharing.
Sir, you did not understand what we are saying, sir.
Please repeat.
We say that at 9 a.m. tomorrow we have another lab of another course at this time.
Oh, you have another. But how many of you? If you miss, you can go through the record or discuss with others. Okay, or you can also discuss with me. Okay.
Okay, sir.
Maybe 100% presence sometimes not possible for some reason. Okay, I understand that, but we'll consider that. But make sure you cover everything. That will be good for you also.
Okay, thank you, sir.
Okay, I'm sharing. Okay, I am sharing two documents. Okay, you can go through. Yeah. Okay, check. Sure. You can download. You can also go through. Then you can study further.
Sir, it's
Okay.
filled to download.
Sorry,
Can you send the first one again, please?
first one.
Yeah, it's filled to download.
Which one, net or one technology?
Net.
Net. Okay, sent successfully. Check whether it can be downloaded.
Yes, sir, it's done. Thank you.
Okay. Okay, thank you. Just study yourself. And if you face any problem, let's discuss. And we'll continue tomorrow. Okay. Thank you all.